So next we introduce us to the concept of machine learning. But before then, we quickly take you through phases of data analysis in research, because we assume that most of our participants are researchers, and we just to show you a few stuff that might be of use. Of course, you're expected to carry out extensive literature review in your research, which should naturally lead you to the understanding of a problem set or finding a research gap. Uh, we assume that if you have read your literature extensively, you'll be able to determine the nature and structure of data you may require for your to solve your problem set or to address the research gap. And if you obtain the raw data, depending on the source, there might be need for data extraction or data cleaning, as the case may be, to sort the data into required form. Because usually when you obtain data, you might not be able to process it in that raw form that you have obtained it. You may have to carry out some cleaning processes or sorting, as you may want to call it. And then usually before you proceed to carry out any analysis at all, once you have uh, your data set ready for analysis, you are advised to carry out data visualization. That gives you a basic information of the nature of the data, the implications of the data set. You'll be able to compare after your analysis to be sure that you're in line. Then you may proceed after your data visualization to carry out your statistical analysis. Depending on your work, you might need to develop some model. You might have to stop at statistical analysis or maybe develop some models. And then, of course, whether you have carried out statistical analysis or model development, in fact, or both, there's always the need for performance evaluation. You have to evaluate the performance of your machine learning models or your statistical analysis model. The statistical model you have developed for your analysis, you have to carry out the performance evaluation, and of course, you have to compare this with other methods to be sure that you have recorded some achievement, and then you can proceed to your result interpretation and report writing. You look at this block diagram has given you a breakdown of what the methodology covers. So methodology covers most part of the data handling, because that tells you the technique you are going to employ and what kind of result you are expected to get. The kind of expected results determine the technique that will best be suited for your work. And so that's it. The last part basically discusses the results and discussion of your work. So we hope that this little step might be of help in your research. So we quickly look at introduction to machine learning. Machine learning is the process of teaching a computer system at a very high level on how to make accurate predictions when fed data. It is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Uh, Depending on the area of applications, machine learning models could be applied to help answer whether a piece of fruit in a photo is a banana or whatever, to identify an object, so to say, identify if a human or any other animal or an object passes in front of an installed camera, identify, so you see identify. So basically, for identification, identify the intent of a word in a sentence, e.g. sometimes we can also develop a machine learning model to help us infer meanings to the use of words, like we normally witness while using our Microsoft Word. You constantly are giving predictions, and when the system assumes that something is wrong, underlines your word or highlight it to, draw your attention. Then machine learning models can also be designed to determine whether an email is a spam or not, or to recognize speech accurately enough to tell which country the speaker comes from, using our intonations and what have you. So a key difference from the traditional computer software is that a human developer hasn't written codes to instruct the system on telling the difference between uh, any given object. And what we mean here is, in machine learning models, you can easily build your model to infinitely continue to whether identify objects, to be able to give distinctions between two objects without having to write a code and say, okay, this code identify this, then you write code to identify that. This machine learning models makes it seamlessly easy for us to toy with. So instead of machine learning, instead a machine learning model has been taught how to reliably discriminate between the fruits by being trained on a large amount of data set. The process of learning begins with the observations of the fed dataset to study the trend and patterns or structure and order, and correlate with inbuilt general specific pointer in order to make better decisions in similar samples that will be provided. So what this is saying is that instead of writing codes, machine learning model is taught on how to discriminate between two objects. This process usually involves it processing the fed data set to study its trend, its patterns, its structure, to correlate with an inbuilt general specific pointer in order to make better decisions in similar samples that may be provided for inferences. So the primary aim is to allow the computers learn automatically without human intervention or assistance and adjust actions accordingly. But there's usually a problem in this field that we also want to look at in this course, and that is telling the difference between machine learning and artificial intelligence. Many people think they are the same at a point. Some people get to ask what the basic difference is. So we quickly look at that. Artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. Basically, AI is a term used to denote that a machine can be programmed to solve problems or by learning like humans to help solve complicated tasks faster. It also describes a machine programmed to perform a task by the application of human intelligence. Uh, Artificial intelligence also help in learning, listening, planning, problem solving, and what have you. The approaches adopted to achieve artificial intelligence are machine learning, evolutionary computations, which involves several optimization schemes, and the application of expert systems based on definition of rules. So this tells us that machine learning is just one of the ways of achieving artificial intelligence. Machine learning models uh, help us to simulate human intelligence in machines, so that such machine can behave like humans. So of course, we could also there are also other techniques of using evolutionary computations involving the use of optimization techniques, various heuristics and meta-heuristics and optimization techniques, and all the application of expert systems. such as fuzzy rules and what have you. There are so many expert systems. So, but now we hope that you can tell the difference between machine learning and artificial intelligence, because the basic difference is that machine learning is just a technique for achieving artificial intelligence. That's all. So types of machine learning. Uh, in this course, we also quickly introduce you to supervised machine learning. Machine learning techniques are basically subdivided into three: supervised machine learning, unsupervised machine learning, and semi-supervised machine learning. Supervised machine learning algorithms applies what has been learned from a labeled sample data uh, to a new data for the prediction of future events. Starting from the analysis of a known training data set, the learning algorithms produced inferred functions to make predictions about the output values. The system provides target for any new input after sufficient training. The learning algorithms also compare its output with the correct or intended output to find errors in order to modify the model accordingly. In supervised machine learning, we have a data set, we have a large data set. Part of this same data set is used for training the machine, and then the remainder of this data set is used for coordinating the output. Usually in this data set, we have what the output should be, or what the expected outputs. And so it is called supervised machine learning because the output of the model is always compared with the expected output to see what errors are recorded. And this is for the purpose of improving subsequent classification or prediction, as the case may be. So in unsupervised machine learning, you give a data set that does not uh, give what the output should be like. So this is the basic difference between supervised and unsupervised machine learning. The unsupervised machine learning utilizes training information that is neither classified nor labeled, meaning uh, an output is not defined for it. They are used when the input variables is available and no corresponding output variables. Unsupervised learning helps to infer functions to describe a hidden structure from unlabeled data. The system doesn't explicitly figure out the right output, but it explores the data, and inferences can be drawn to describe hidden structures from the unlabeled data. Types of machine learning continues. The last of the classification is semi-supervised machine learning. This falls in between supervised and unsupervised learning, as they utilize both labeled and unlabeled data for training. Usually, a small amount of labeled data and a large amount of unlabeled data are utilized for training. Take note of these basic differences. In semi-supervised learning, only a small amount of labeled data and a large amount of unlabeled data. So most data analysts still refer to this procedure as unsupervised. Excuse me. So learning accuracy are considerably improved using semi-supervised learning. The main aim of supplying a small amount of labeled data to help us uh, is to improve the accuracy, the learning accuracy. So usually semi-supervised learning is chosen when the acquired labeled data requires skilled and relevant resources in order to train it. Otherwise, acquiring unlabeled data generally doesn't acquire additional resources. So usually what we mean here is that when you have unlabeled data, you usually don't require additional resources to process the data using relevant machine learning models. But usually, semi-supervised learning is chosen when there is the need for the labeled data, uh, when the labeled data requires some skills and relevant resources to help its training process. Oh yes, reinforcement learning. They actually form. Reinforcement learning is a key aspect of machine learning models that has also uh, come to be enforced, especially with the advent of robots. This learning method interacts with the environment by producing actions to discover errors or rewards, which it uses to improve itself. So it's basically a trial and error procedure, which are relevant characteristics of reinforcement learning. It's just a trial and error procedure that, for instance, you develop a robot using a reinforcement learning technique, such that if this robot carries out, performs one action, it tries to look at the output. If it's satisfactory, then there's no need for improvement. If it's not satisfactory, based on whatever the error is, by the time the robot has to perform that task the second time, you can assure that there will be improvement. So this method allows machines and software agents to automatically determine the ideal behavior within a specific context in order to maximize its performance. Simple reward feedback is required for the agent to learn which action is best. This is known as the reinforcement signal. In this type of machine learning models, there is a key factor known as reward feedback. The reward feedback means determination of likely error. You know, it is also known as reinforcement signal, which the machine helps, which helps the machine to determine if it should improve its accuracy or if there is no need for further improvement to enable the performance of such task seamlessly. So here we give a summary of the machine learning types. Supervised machine learning. Under supervised machine learning, we usually carry out prediction, classification, and what have you, regression. Under supervised machine learning, we usually carry out clustering, probability distribution estimation, finding associations in set of data, or dimension reduction in a set of data. So semi-supervised learning enhances supervised and unsupervised learning, while reinforcement learning usually involves decision making, usually utilizes decision making approach. Uh, that's that. So let's quickly look at examples of machine learning models. There are a lot of examples, and I'm sure some of us may have come across them: linear regression, logistic regression, decision trees, support vector machines, the k-nearest neighbors, k-means assembly languages, and what have you. Neural networks. We have variants of neural networks, random forests, and gradient boosting algorithms for various tasks, depending on the choice of the relevant machine models. Actually depends on the task, so you will need further training on this to be able to determine which of the machine learning model is applicable for your work. So we give some illustrations here. If, for instance, you're given this data set, you have age and height, corresponding height, and you're to determine, to predict height of a certain age, in this case, predict the height of an 8-year-old. If 5-year-old has this height, 7-year-old has this height, by mere relational uh, event, we can be able to determine, okay, an 8-year-old should be of this height. This is an example of what supervised machine learning looks like. You've given input, you've given the likely output, and so you can now choose a random input and ask the computer to tell you what the output should be. So using this output as training uh, data set. So it's like you are supervising this learning model by using this set of output, and so that's why it's called supervised learning model. It's a perfect example of a supervised learning model. So here we try to illustrate KNN, k-nearest neighbor. To apply k-nearest neighbor usually involves uh, determining which neighbors are closest to the point of interest. If, for instance, you have this data set, this represents event A, this presents another event, and you want to see relations you have an interesting point between these two data sets. In this case, shown as this love sign. Let's assume we are more interested in this point. We want to see what's happening at this point. To apply k-nearest neighbor means which of the points are nearest to your point of interest, and that is shown here. It is, if you are to this depends on the number of k. If k is 1, that means you have to choose one closest neighbor. If k is 2, you have to choose 2. Let's assume we have to choose only 2. We will not be choosing from these squares. We'll be choosing from the stars. If k was 2, so because k is 3, we choose this. If k is increased to 4, we can now look which one is the closest. Remember, because we are dealing with very low points, so we are able to start thinking which one is closer. Even at that, it will soon get compounded. That if let's assume k is 10, that means you have to look for the 10 nearest points from the two sides of the data. 10 nearest points. Of course, you can easily tell that that will be very difficult for us to estimate, but the computer system uses Cartesian coordinates of these points to determine which is the closest to your point of interest. So by using Cartesian coordinate, KNN task is solved by merely identifying point of interest close to your, the points that is close to your point of interest. So this is how KNN works. If you just identify your point, okay, I want to, this point is my point of interest, you're able to determine your point of interest and carry out further analysis based on the selection. Decision tree is another perfect examples of these models. We have a very simple illustration here. You have a person who eats a lot of fats. Oh, sorry. This should have been fats. F-A-T-S, not fast. F-A-T-S, fats. You have a person who eats a lot of fats. Yes, so you can assume the person is unfit. If the size no, you can assume the person is fit. This person doesn't, you have a person who doesn't eat, you have a person who exercises regularly. Okay, I think this diagram, I didn't get it correctly. I intend to show a simple illustration of this person eating a lot of fats. You say yes. If you say yes, then we can assume the person is unfit. If it's no, you can assume the person fit. But does this person exercise regularly? If yes, then we can assume the person is fit. If no, the person is unfit. It's just a matter of drawing your decision variables to determine your output. Oh yes, okay. I think we corrected this. Okay, I think I corrected. So this person exercises regularly. You have a person, yes, yes. This person eats a lot of fat, yes. Then it's unfit. This person eats a lot of fats, no, then he's fit. This person exercises regularly, yes, he's fit. He doesn't exercise regularly, then he's unfit. Okay. We have another illustration, excuse me. We have another illustration of a neural network. This is what a neural network looks like. Input, this is output, and these are the hidden networks. The perfect example is we can best illustrate this by our own human self. If you are given a set of data, say 2, 4, 6, 8, 10, and you have to predict the next set of data, I want to assume that is easy for all of us. You are given a set of data, say 2, 4, 6, 8, 10. You can easily continue to say 12, 14, 16, and what have you. Similarly, if you are given 1, 4, 9, it is easy for you to continue, say 1, 4, 9, 16, 25, and what have you. So similar thing happens in neural networks. Neural networks uses connections between inputs through some hidden layers to generate output. Of course, these calculations of the hidden layer networks parameters is done using a weighted factor. You give some set of inputs. These inputs they try to look at this input, how they relate to each other, how these inputs relate to one another to generate what the output will likely be. So this is neural network has a lot of variance, uh, but you have to study these models to also know how to use them. You need to study further, not so difficult anyway. So a very key aspect of machine learning is training and testing of our data. Training is the process of making the system able to learn, while testing is the evaluation of the performance of the model. The data is often split into two unequal sets. The larger set is often for training, while the lower set is for testing. Usually, when you have a data before you go into processing this data, you split this data into two unequal sets, say 70-30, 60-40, depending on your desired ratio, depending on the application, 80-20. 50-50 is the worst case scenario. Not advised, but some people still use it, but not advised. 60-40 should be the minimum. So the larger set is often for training, while the lower set is for testing. So training and testing is done by obeying the no free lunch rule. Training set and testing set come from same distribution. Some assumptions or bias are made. So performance of machine learning models, performance evaluation expresses the accuracy and reliability of the developed model. Several factors affect the performance of machine learning models. The types of training data, the training testing data ratio, the form and extent of any initial background knowledge, the type of feedback provided, and what have you. So applications of machine learning is applied in so many fields for face detection, anomaly detections, object detections, image segmentations, and what have you. Thank you. We shall meet later uh, in the evening from my side, in the evening for interactions on what we have presented so far. Thank you.